Great, thank you. I would like to speak to you for a few minutes about a project we've been working on at UC Santa Barbara, where we are taking the Introduction to Geospatial Data Carpentry lesson and turning it into a local atlas of campus for some very specific reasons that I'll talk to you about. I think this audience knows what the Carpentries is for the most part. But very briefly, when we teach carpenters workshops, we live code. So the instructor is typing line by line. We're not running a defined solution set. We're typing from scratch, and they're intended to be very hands-on, typically between 2 and 3 business days. That's hard to do these days. So we are breaking the lessons down into smaller modules, and each episode in the lesson is usually under 2 hours. The geospatial lesson is 14 episodes. It's way too big. It's way too long, but that is partially why we've attacked this our Atlas project. And Carpentries is also a nonprofit organization that designs these open educational resources and trains the instructors. So that paradigm goes also with openness. So we rely heavily on open source tools like R and Python when we teach, Git Bash, things like that. We are always trying to include reproducibility and project management in our lessons, and the Carpentries has some of that. We're really trying to emphasize those pieces and insert more of that into what we call them the canonical lessons, the lessons as they're written. And then we use the Carpentries materials to teach these skills, and also we try to use the tools on a day-to-day basis. So we've moved most of our work into GitHub and Git pages. That's not something we did before we started teaching Carpentries. And in that spirit, I've never used Cordo slides before today, so this is my first ever Markdown slideshow. Yay! And that's Charlotte. She's still available for adoption if you'd like. So we started teaching carpentry lessons in 2019, and right from the start, I realized I don't have the skills to teach these classes. I can traverse a directory structure, but I cannot code geospatial R off the top of my head. So I had a real steep learning curve, and we noticed that other instructors had a similar learning curve where the specific tasks in the lessons were not tasks we were using in our day-to-day life. So that's what inspired the project, is I can teach this lesson, which uses data from a Harvard test forest and a San Joaquin ecological reserve, but like I don't know those places. So I started trying to recreate the entire lesson using local data sources, using my local campus data. So we wound up with some real groovy looking mistakes along the way, but we have gradually started to make nicer looking maps. We've come a long way. A real classic problem when you're teaching a carpentry workshop is you expect people to have RStudio installed when they arrive. They often don't, or they often have several versions back, and they haven't loaded the libraries that we've asked them to run. So one thing we've managed to do is there is a campus service that's for instruction, which has a Jupyter Hub, which allows us to run RStudio just in a web browser. And that was the first time that a non-credit class ever used that facility on campus. So we're helping to broaden the reach of these purely academic resources. I've also become a maintainer of this lesson myself, which means I'm supposed to accept pull requests. Unfortunately, sometimes I have to accept my own pull requests because I'm also sort of the ad hoc chair of the curriculum committee for this lesson. So typically in Carpentries, you're not supposed to wear both of those hats at the same time, but we're doing it anyways. And more recently, as people are coming in with code that has been generated or co-generated by Gemini or Copilot, we're arguing with those autocompletes. No, I named my variables this. Well, I want to use camel case. So Copilot, it's difficult to work with sometimes as a coworker. So we encourage people to turn it off for the sake of the lesson. So basically, we started I call it the rAtlas. We started this as soon as we came back to the office after the quarantine, and we were making very slow progress making these maps, going from episode to episode, trying to recreate the learning experience of the workshop. So finally, we made a weekly appointment with a small team of people. And that was very effective to keep us moving forward and to keep us honest with each other. The other thing is we have a real strong set of local data resources. We have a nature reserve next to campus. That's a recently renovated golf course. It's being brought back into a coastal wetland. So there's tons of sensor data from out there. We have our official campus data that we're able to use, local data sources. And finally, something to speed the work along, we didn't change the lesson at all. Like when the lesson calls for 1 DEM of the Harvard forest, we have a digital elevation model of our campus. When the lesson calls for a second digital elevation model, we put in a bathymetry model instead. And now locally, that works great for us because there's a subtle little difference between an elevation model above the ground and an elevation model below the ground, and where the two meet is not always the same. A bathymetry model almost never starts at 0. It starts at like plus 5 meters. And a coastline is never, I mean, think about the ocean. Where is the coast? Is it where the water is? Well, the water's moving constantly. We'll zoom on this map a little bit, and I'll show you why bathymetry is such an interesting example for us. The overall strategy, this might be a little repetitive, but we really want the entire project to be runnable from start to finish. We want everything to be open, so all of the data has been republished if it's not in a really readily accessible place. All of the data is local to our community and very relevant. This will be hard to see. There's some very small red dots on here. Those are eucalyptus trees. They were planted by the original Anglo ranchers near us, and now 100 years later, 150 years later, they're causing us a problem because they blow up in wildfires. So we're gradually removing all the eucalyptuses. So what makes it runnable is we have a little script that just has a loop in it that says episode 1, episode 2, episode 3. Same thing with all the maps. Now, what's the difference between an episode and a map? If you were to go through the lesson, they don't really make nice maps. They are the data sets are in there as teaching examples, and I realized pretty quickly I can't make the episodes unless I have the project finished at the same time beforehand. And we needed to do a little backwards design. So we stopped working on episodes and we started working on maps instead. And that was a good move. Also, at the beginning and the end, at the beginning of every script, we clean our environment and we unload all the libraries, which is something that the Carpentries don't emphasize in their existing lessons, but we have found it to be a really, really good practice when we're working. Like 2 hours in, you've got a bunch of data loaded, you've got a bunch of objects in memory, and if you go on to the next episode, you might get unexpected mistakes, or you might skip things and things might work that shouldn't be working because you've already loaded things from a previous hour. So clean environments, good project management, a clear and consistent folder structure. Here's a problem with Copilot. One of the lessons we always teach people when we're teaching people to code is pick a consistent naming style for your files, pick a consistent naming convention for your objects. Copilot does not do that very well. Copilot will do final_final because it was taught by humans who are crappy file namers. So it's like literally the AI learned our bad habits. And so we have tried to make a clear and consistent folder structure, clear and consistent file and object names. And again, this is published as an open repo for everyone. The only part that I would say is not open is these satellite images are from Planet Labs, and that is a proprietary fleet of satellites, constellation of satellites. We happen to have a subscription right now, but our subscription, when it runs out, allows us to keep the data forever. So we will be able to continue to use the data that we've downloaded. I think it's really important for the learners on campus to have a concrete mental model of what they're mapping. When you're first starting out, and I guess you'll just have to trust me on this, how many of you are geospatially aware kind of GISE people? Yeah, if you're mapping someplace you've never been, it's a little bit harder, right? Like it's a lot easier to map something you know. It's a lot easier to find the mistakes if you know where the bathrooms are, as opposed to where the data tells you the bathrooms are. So we're using library collections. We're using our own campus facilities data. I already told you about that golf course. And we also have some beautiful partners at the Cheadle Center who do, well, at the moment, they're capturing a lot of bees on campus and distinguishing between the different species of bees around. So I have an assistant who goes out with her butterfly net a couple days a week and comes back with little cups filled with bees. And at least for the moment, we have access to all of the data that the American government makes available. Of course, thanks. So part of this, why local matters so much, is it helps my campus community to learn that we have these local data sources. Not too many people think, oh, I'll go to the library if I need a shapefile of the bike paths, or I'll go to the library if I need some census data. That's not yet really ingrained in people. So it's really good outreach for us. And this scale of campus, this cognitive scale where you can ride your bicycle in 15 minutes from one end of the map to the other end of the map, that's a really good cognitive scale to work at. It's a little bit bigger than a neighborhood. It's a little bit smaller than a city. And that's, I think the learners are very, very grateful that we're not using the Harvard test forest anymore. Oh my gosh, I went really fast. How much time do I have left? I got tons of time. I got 6 minutes left. That's so amazing. So one of my immediate tasks when I get back and for the whole team is we want to go back to the very beginning and start doing this all over again in QGIS. And then we're going to do it all over again in ArcGIS. But we're going to use the same lesson and we're going to use the same data. Again, our time is very precious. We're spending a lot of time arguing with Copilot, so I don't want to have to write a whole other lesson from scratch. So we will, as I've been trying to say more often, we will try and catch 2 butterflies with 1 net. We don't throw stones at birds anymore. And there are additional data sources to go out and exploit and use. So this is a wildfire from just last month in California. We are down on the bottom on the coast here, and you can see that smoke comes down and affects people on campus on a day-to-day basis. That went very fast. That was literally my last slide. So we have time left for questions. Oh, sure. So that was the first slide. So thank you for having me back up. So the Carpentry is both a nonprofit organization and it's a method of teaching with live coding that's been developed. So the organization has these community written lessons. There's about 20 of them, and they scaffold very nicely. So a very typical quarter for us, we work on a quarter system, is we will teach introduction to the bash shell and teach people how to use a file editor, where are your files, a little bit of grep, But most importantly, what a directory structure is. That is something that undergraduates are coming in not knowing anymore. The organization has a instructor certification process. Our membership in the organization lets us put 12 people a year through that process. And then all of the lessons that the Carpentries make are open educational resources. So they're free for reuse, they're free for editing. Oh, I was talking about the scaffolding. So we start with the bash shell. We will then move on to collaboration and version control with Git. And then we'll teach an introduction to R. And then we'll teach introduction to geospatial data or introduction to camera traps is another lesson that's being taught. There's a introduction to social science data with R that's being taught. So there's a big selection of official, fully vetted lessons, and then there's a big backlog of draft lessons that are in what's called the Carpentry Incubator. And actually, there are at least 3 people here from the Carpentries as an organization, Sharon and I'm really bad with names, but yeah, you can chat with them more if you'd like.
This is great. So just to be clear, the target audience are researchers. What type of researchers? Are they undergraduate, doctorate?
Sure, thank you. So our target audience at UCSB specifically are advanced undergraduates and entry-level graduate students. We see a lot of grad students arrive on campus to say, like, I came here to learn how to code for ecological data science in Python, and their departments say, no, you were already supposed to know that when you got here. And so we observed pretty early on that there's this growing divide amongst the computational aware graduate students and the ones that aren't. And the ones that aren't, when they get there, it's not in the curriculum. And there is this barrier to entry. And we saw really concretely differences in the jobs that the graduate students were getting. And it was gendered too. So literally all the boys got research jobs. All the girls wound up ordering sandwiches and organizing meetings. And it was ugly for a couple of years. And now I have a really nicely gender balanced cohort of instructors. And Santa Barbara has a really active Our Ladies chapter that runs a lot of open meetings. And I think we're doing a good job of closing a gender divide.
If I may, we help with, so the NSF funded this project for the National Secure Data Service. And what one project they had was, how do agencies know how their data is being used by researchers? And one lesson we learned is researchers do not cite the data.
And you remember how I was talking about good project management and good behavior? Citation is in the lessons,
but so that's good.
But it's one of those things that's not emphasized. And so as we become more active and we're having more influence on the lessons, we are embedding that sort of information into them.
Great. I just want to make sure it's.
All right, we have 1 minute left. Any last questions? All right, on that note, I'll do the honors. How can we get involved if we're interested?
Oh, you betcha. So Carpentry is completely open. You don't have to be a member. All of the lessons are publicly available repos on GitHub, and you can just read the instructions and start making contributions to lessons. You can pick an issue and solve the problem and do a PR, or you can join a Slack, join a community meeting and get an introduction to the community. The Carpentries are a great bunch of folks from all over the world, from a real diverse set of disciplines too. So thanks for the leading question.
Well, thank you so much. And this concludes the session.